Hey, students. So this is the last daily work for the sorry, the third 9 weeks um, of the school year. So are they saying the same thing? So this was another one that was really based on finding the equivalent expressions in instance, because the next lessons that we would do is based on equations and inequalities, and they are slightly different than expressions. Although they have some things, many things in common, as a matter of fact, but they are slightly different. So this homework was only 2 pages. So starting with this particular part at the top, you once again read the directions, and you didn't have to do number 6. I skipped number 6 entirely. You only had to do 1 through 5, and you only had to match. Honestly, if you didn't know what these properties were or even what this meant, you really can just look it up. These things are told in the packet themselves. So if you still have lesson 4, are they saying the same thing? Just go throughout the packet. It literally has the vocabulary for these terms. So please use the packet to answer this top part. It's very easy. Remember, anytime we're doing something off the assignment page, it is going to give you something to remember. So you just read it and try to understand that this is kind of important for you to know. The practice was on there. Now, for these practice problems, once again, read the directions. But it really wanted you, or I really wanted you, let me say that. I'll say it that way. I really wanted you to practice some of the properties that you just listed or learned about here. There is one property missing because it was talked about earlier in the school year, but it still applies now. And because I have seen students have only a little bit of trouble with this, I am going to do one problem so you can kind of see what you needed to be doing for this. I know it says use a table and a graph. I would prefer, for simplicity's sake, it probably would be best if you do the table instead of the graph. Because if you're making your own graph, like if you don't have graphing paper, then your lines won't be as straight as they need to be. And I don't need you to assume. But the table, which was used in this lesson, because it showed you 3 ways to check if an expression was equivalent or not, using properties, which is the one I'm going to use. And you can also use a table if you don't know how to use a property. The table was using substitution. So all you have to do is think of a number, and you usually need to think of at least 2, one small and one a little bit bigger. Put them in for the variable, solve that expression, and see if the expressions have the same answers. If they do, then they are equivalent. If they don't, then they're not. But this is also why you have to use 2 numbers if you're going to use the table. Because if you use 2 small numbers, they could just be equivalent because you're using numbers that are relatively close together. But if you use one small and one a little bit larger and they don't equal the same, then that tells you they kind of fall off somewhere. But if you use one big and one small and it would still wind up being the same, then it means it doesn't matter what number you use, they're still going to equal the same amounts. I'm going to do number 4. The rest of it is for you to do. Okay, so let's look at this first one. So the first one has a lot going on, but once again, it's easy if you know what to use. Since I have addition, this is right here is multiplication, the line is division because fractions are related to division, and then we have a plus. I have like 3 different operations going on, so you use order of operations. So I'm going to use order of operations on this, which is not exactly a property, but it's similar enough. Now, order of operations tells me to do grouping symbols first. So because this is in my numerator and my numerator should only be one number, then I'm going to simplify this. The only problem is I can't, because this number, this coefficient, has a variable. This is a constant. Constants are numbers without variables and they don't change. This 6, since it is with a variable, means this number can change depending on what the x is. So I can't combine these two. So let's continue on. Well, next, they are being divided by 3. Now, can I divide these numbers by 3? I actually can, because 6 divided by 3 gives me 2. Now, this is a 2x, because all I did was change the number. I did not change the variable. Plus, and I can't change the operation, 9 divided by 3, which is 3. So that takes care of this. I have now simplified it to this plus this, because that is still a part of the problem. Now, the next thing, I have 2x plus 3 plus 4. Well, I have two constants that don't have variables. And they have the same exponent, which is 1, because 1 equals themselves. So I'm going to add this together because both of them are positive. So that gives me 2x plus 7. So that means this one on the left equals 7. It equals 2x plus 7. Now, let's look at this one. Now, for this one, I can also use order of operations because I have multiplication here and addition here. The only problem is I can't add a variable with a number that doesn't have a variable. So I have to work on something else. So I can't add these two together, but I can still multiply because I can multiply with variables or multiply numbers and variables. So I would multiply this times this and this times this. So 2 times x gives me 2x plus, because once again, I cannot change the operation. 2 times 3.5, well, that doubles up and gives me 7. So this one equals 2x plus 7. This one equals 2x plus 7. So that means this particular, these two expressions are equivalent to each other. So I would just put equivalent and move on. All right, now let's go to the next page. The next page had the stretch. Once again, this would have been a nice stretch to do, but since I already set the precedent of no stretches, we're not going to do that. But you do have the rest of this to do for the review. So, distributive property. You needed to use the distributive property because you could not use the order of operations as is. Because looking at this one, we have 6m plus 3, which is inside of parentheses, and we would normally add, but you can't add a number that has a variable with a number that does not. Same thing over here. But you can still multiply anything in these parentheses with the numbers that are touching their parentheses. And then, of course, you can combine like terms as long as the terms have something in common. If they have a variable, it has to be the same variable. If they have an exponent, it has to be the same exponent, and things of that nature. If they don't have anything, which means they are constants, like the 3 here is a constant, it doesn't have a variable, nor does it have an exponent. If it's a constant, other constants can be added or subtracted from it because those can be combined together. So remember, you are using the distributive property, but you are also combining like terms, but they have to be alike. If they have a variable, it has to be the same variable. If they are constants, you can only combine them with other constants. And of course, they have to have similar exponents. So if the exponents are not in common, then you cannot combine like terms. This one is like the third one I didn't gave y'all, determining the better buy. Once again, I explained this in a previous assignment, and in the last assignment, which was second verse, same as the first, that one was asking for faster. So like I said, it depends on what you're trying to compare, depends on what you're looking for. Because like I said, since this is a better buy, we are looking for something that's going to give us the most for the less amount of money. So it's your job to figure out which is which. I don't remember what lesson I actually solved one of these in. You would just have to go to the previous videos in the Daily Works folder uh, to look it up. Because, like I said, honestly, I don't remember. Now, 5 and 6, I I don't know how to say this, but if you do not know after reading this how to find it, I would suggest you look it up. If you do not have the notebook or you were not in my class around August of last year, then you may not have notes on this. And like I said, depending on how much you wrote in your notebook, you may be on your second notebook in my class because some students are, because that's how much it took to write. So least common multiple is not that hard because least common multiple is related to products. Least common multiple, the multiple is the answer to a multiplication problem, just like the product is the answer to a multiplication problem. So you are basically looking for when these two numbers have the same product, like when they have the same answers. That's really what it is. So if you need further help, let me know and I see what I can do. But until then, bye.